ISRO accomplished the successful launch of India's inaugural solar mission, Aditya L1, from Sriharikota on this Saturday 2nd September 2023. Aditya L1 is a pioneering space observatory designed for solar studies and was launched into space using ISRO's Reliable Polar Satellite Launch Vehicle (PSLV) at precisely subah ke 11:50. After embarking on a journey spanning approximately 1.5 million kilometers from Earth, which is expected to take 125 days, the spacecraft is slated to be positioned in a halo orbit around the Lagrangian point L1, the location closest to the Sun. The primary goals of this mission encompass comprehending phenomena such as coronal heating, solar wind acceleration, coronal mass ejection initiation, as well as gaining insights into near-Earth space weather and solar wind distribution. Aditya L1's mission payload consists of 7 scientific instruments dedicated to conducting these investigations. Named in honor of the Sun's core, Aditya L1 is set to offer unparalleled insights into solar behavior by positioning itself in a halo orbit around Lagrangian point 1, L1, within the Sun-Earth system, situated approximately 1.5 million kilometers from Earth. This strategic location will enable Aditya L1 to continuously monitor the Sun without any hindrance from eclipses or occultation, facilitating real-time study of solar activities. The spacecraft is equipped with 7 advanced payloads, including electromagnetic, particle, and magnetic field detectors, all meticulously designed to scrutinize various layers of the Sun, encompassing the photosphere, chromosphere, and even the outermost corona. What makes this mission particularly exciting is its unique vantage point at L1, allowing 4 payloads to capture clear solar observations, while the remaining 3 payloads will conduct in situ studies of particles and fields at this Lagrangian point. These combined observations hold great promise in unraveling the enigmatic facets of solar dynamics and their implications for the interplanetary medium. Aditya L1's payload is expected to provide valuable insights into the physics of the solar corona, its heating mechanisms, magnetic field configurations, and the processes leading to coronal mass ejections. Ultimately, the data collected by this spacecraft will contribute significantly to our understanding of space weather drivers. Here is a summary of the layers of the Sun. Core, the central region where nuclear fusion occurs, releasing massive amounts of energy in the form of light and heat. Radiative zone, energy from the core moves outward through radiation, taking millions of years to reach the surface. Convective zone, energy is transported through convection, with hot plasma rising and cooler plasma sinking in a continual cycle. Photosphere, the visible surface of the Sun, emitting the light we see, with a temperature of about 5,500 degrees Celsius. Chromosphere, a layer above the photosphere, characterized by a reddish-pink color and temperatures ranging from 4,000 to 20,000 degrees Celsius. Transition region, a thin layer between the chromosphere and the corona with a rapid increase in temperature. Corona, the outermost layer, extending millions of kilometers into space, extremely hot, with temperatures exceeding 1 million degrees Celsius, and visible as a glowing halo during a total solar eclipse. The Sun emits various types of rays and forms of radiation. Here is a summary of the different rays and radiations originating from the Sun. Visible light. The Sun emits a broad spectrum of visible light, which is the primary source of illumination for our planet and allows us to see objects. Ultraviolet. UV radiation. The sun emits ultraviolet radiation, which is invisible to the human eye. UV radiation is responsible for causing sunburn and can have both harmful and beneficial effects on Earth, such as enabling the production of vitamin D. Infrared IR radiation. Infrared radiation is another form of electromagnetic radiation emitted by the sun. It carries heat energy and is responsible for warming our planet. X-rays and gamma rays. These extremely high-energy rays are also emitted by the sun, primarily during solar flares and other energetic solar events. They can have harmful effects on satellites and communication systems in space. Solar wind. The sun constantly releases a stream of charged particles, mainly electrons and protons, into space. This flow of charged particles is known as the solar wind and can interact with Earth's magnetic field, leading to phenomena such as the auroras, northern and southern lights. Neutrinos. Neutrinos are nearly massless subatomic particles produced in the sun's core as a byproduct of nuclear fusion. They stream out of the sun in enormous numbers but are extremely difficult to detect due to their weak interactions with matter. Magnetic fields. The sun's magnetic field is not a form of radiation but plays a crucial role in solar activity. It generates phenomena like sunspots, solar flares, and coronal mass ejections (CMEs), which can impact Earth's space environment. If you find this scientific content useful, please like, comment, share, and subscribe for more such videos.